Today's day 2 of adding and subtracting rational expressions. I'd like to start with a little warm-up problem. It's asking, why isn't x plus 1 cubed the least common denominator of 1 over x plus 1 and 1 over x plus 1 squared? And what really is the least common denominator? I put this here because there was a question in the past that I did with my students, and a lot of people did put the incorrect least common denominator of x plus 1 cubed. What they did was they multiplied x plus 1 by x plus 1 squared. And if they multiply those together, it does in fact become x plus 1 cubed. However, even though x plus 1 cubed would be a common denominator, it's not the least common denominator, and that's what we want. We want to multiply it by something in order to get the same thing. Now, yes, you can multiply x plus 1 squared by x plus 1 to get x plus 1 cubed, and we'd have to multiply x plus 1 to the first power by x plus 1 squared to get x plus 1 cubed. Or what we could do is just multiply the x plus 1 to the first power by x plus 1 once again. Because something times itself is that something being squared. So what really is the least common denominator? It's x plus 1 squared. Okay? Or in other words, another answer would be because x plus 1 is the highest power. Remember how in a previous video I said if we have x, let's say squared and x to the fourth power, you'd want to pull the biggest power because I can just multiply the lower power by something to get that. That's essentially what I did here. All right, the steps for adding and subtracting are the exact same from the previous video, which is your 5.3 day 1. So we're still doing that. I'm just increasing the difficulty of the problems slowly but surely. We're going to start off with example 3, part A. I'm adding here, okay? So there's not going to be as many sign mistakes, I don't think, here. When we add, the first thing we would like to do is factor the denominator of each term if possible. So this one doesn't factor, but this one's a case 1 trinomial, which means we can use guess and check. I know that the factors of 2 are 1 and 2, and they need to be same sign. So I'm either going to put plus, plus, or minus, minus. Since my middle term is a positive 3, I know I'm going to put plus, plus. Okay, so I just rewrote that. The least common denominator is the next step. We multiply the similarities by the differences, so they both have an x plus 1. I'm going to multiply that by the one difference, which is x plus 2. Now we need to see if we need to multiply one or more terms by a ratio in order to get a common denominator. Notice how the first term already has both. So I won't have to multiply this by anything. It's just going to stay x minus 1 over x plus 1, x plus 2. Plus I have my second term, which is just over x plus 1. So it is missing an x plus 2. We're going to be multiplying x plus 2 over x plus 2. Okay. Now that I have a common denominator, I can rewrite this whole thing over that denominator. And we're just going to add. So I have x minus 1 plus x times x plus 2. Of course, we need to clean this up, so I'm going to distribute that x to each term. So that's x minus 1 plus x squared plus 2x. All right, let's clean this up again. I like to write it in standard form, meaning highest to lowest power. So I'm going to put my x squared first. It doesn't combine with anything else. But I do have some x's that I can combine. 2x plus 1x is 3x. And then minus 1. You should always check and see if we can simplify our answer, which would entail factoring and canceling stuff out. Just by looking at this, though, the factors of 1 are 1 and 1, and there's no way using 1 and 1 and different signs that we can get to a positive 3. So I know that this is my final answer, and now I just need to say when it's going to be undefined. Remember from the previous video, we said all we have to do is set the least common denominator equal to 0. So x plus 1 equals 0 gives me a negative 1, and x plus 2 gives me a negative 2. Let's take a look at part B. Step 1 is to factor. I can factor a difference of 2 squares here. And now I can identify the least common denominator, which would be the similarity, x plus 3, times the difference, x minus 3. The next step, and remember all these steps are right up here if you ever need to look at them, is we multiply the terms by something in order to get the least common denominator. So first I have the x over x plus 3. This is missing the x minus 3. So I'm going to go ahead and multiply it by x minus 3 over x minus 3. My second term, I'm going to write it with the factor form here. It already has both, so I do not need to multiply it by anything. Now that I have a common denominator, I can write this whole thing as being over x plus 3, x minus 3, and I just need to add the numerator. So I have x times x minus 3 plus a negative 18. We just need to clean that up. So I'm going to distribute here, and when I add a negative, that's just going to become a minus sign. So really, this is x squared minus 3x minus 18, all over x plus 3, x minus 3. Remember, we should always ask if I can simplify further. So let's see if we can factor our numerator now that we've added. And let's see if anything cancels. 18 has factors of 1 and 18, 2 and 9, 3 and 6. And we have to use different signs to get a negative 3. That is possible. So the factored form, since this was a case 1, would be x plus 3, x minus 6. So now we can see that we do in fact have some terms that cancel out, and we are just left with x minus 6 over x minus 3. You cannot simplify any further. These x's do not cancel out. You cannot simplify the 6 over 3. And the reason why is because we have subtraction here. These are expressions. They belong together. If that confuses you, leave the parentheses. X minus 6 goes together. X minus 3 goes together. We can't start canceling stuff out. We can only cancel out if we're multiplying, not adding or subtracting. Okay, last thing is to determine when it's undefined. So set each part in the least common denominator equal to 0. That gives me a negative 3 and a positive 3. Example 4, we're subtracting. Remember, we got to be careful with our signs here, and these problems are a little bit trickier than yesterday's. So the first thing is, same steps, like I said, to factor the denominators. So x plus 2, x minus 2. The least common denominator would be the similarity of x plus 2 times the difference of x minus 2. I'm going to go ahead and rewrite this, see if I have to multiply anything. The first term already has both, so I'm just going to leave it alone. The second term, however, is only over x plus 2, so it is missing an x minus 2, meaning I multiply by x minus 2 over x minus 2. Now we're just going to subtract since we have a common denominator. So I have 2x squared minus 16 minus x plus 4 times x minus 2 over the common denominator. This is where I see the sign mistakes, okay, when we're actually subtracting. The first thing you should do here, since I need to FOIL this out, is I would multiply them together and then I would subtract the terms. So if I FOIL this out, I'm just going to write it right over here. I have 2x squared minus 16 minus, I'm just going to put that in parentheses, what all I get. I get x times x, which is x squared, x times negative 2, which is negative 2x, and then positive 4x, and then negative 8. Okay, I am subtracting this whole expression. So we need to distribute that negative to every single term. And if I wanted to, I could have combined my x's. I'm not too worried about it. That's completely up to you. But if I do that, I end up with, I'm going to write it down here since I'm running out of space, 2x squared minus 16x minus x squared plus 2x minus 4x minus 8. And then I can combine like terms. So my x squares, I have 2x squared minus 1x squared is just 1x squared. And then my x's, I just have 2x minus 4x. So that's just going to be negative 2x. And then I have, that looks like a negative 16 minus 8, so that's minus 24. Always check and see if we can simplify any further. The factors of, this is a case 1 trinomial, the factors of 24 are 1, 24, 2, 12, and then 3, 8, 4, 6. Using different signs, I want to get to a negative 2. Oh, I can do that. If you look here, the 4 and the 6, I can have a negative 6 and a positive 4. That should give me a negative 2. Let's go ahead and write the factored form then. X plus 4, x minus 6 is the numerator, x plus 2, x minus 2 in the denominator. So nothing cancels out, which is fine, but we factored it all the way, it's simplified, and we're ready to say when it's undefined. So set both binomials in the LCD equal to 0. That means it's undefined at negative 2 and 2. All right, part B, example 4. We would multiply by the least common denominator, we'd identify the least common denominator right away because neither of these are factorable. So when I look at this, they have no similarities. That means we're just going to have to multiply by the two differences. So I'm going to have to multiply my first term by 5x minus 2. And my second term by 2x plus 5. So that means I'm going to have to FOIL here and distribute here. I'm going to pause the video and do that since I'm starting to run low on time. Alright, so you can see I FOILed here and this is what I ended up with. When I distributed a negative 2 to these two terms, this is what I ended up with. Now I'm going to pause the video and combine like terms. This is what I got when I combined like terms. The numerator is not factorable. And the last step was to set each binomial in the LCD equal to 0, which I did here. Feel free to pause and check.